All right, Unit 3, Descriptive Geometry, the first part. There's two parts in this one, so Part A. And this one we're going to find angular distance. And the way we're going to do that is we got to do a little work here. We got to look at this. Now, the reason this is based upon is working in industry during piping and other things, you're going to find that for structurals and pipes, that typically your sizes, especially corners and your elbows, are going to be 45 or 90. So it's more logical that you use pre-built, already mass-produced connections than it is to make custom connections. So in this particular scenario, we are trying to add a new reservoir to catch the runoff from the roof. We know where the tank is going to be located, which is our O, and we know we need to use 45, but we are not quite sure what the length of the line should be and the angle, etc. So how do we find that? How do we find out what's going on there? So this one we got to do a couple of things. And step one is, of course, to line it up with your horizontal line here and tape it down. I'm trying to get it where you can still see and I can still see. Okay, so I've got it lined up. Where's my tape? Tape has run off. This is not good. Ah, there's the tape hiding me. And tape it in place. And yes, you'll be moving it around a little bit here a little while, but let's tape it down. Okay, there we go. All right. So step one is we're actually going to draw the horizontal line down here in the frontal view from O over to the line. The reason we do that is because it's going to help us to find some things in a minute. So it just makes the little steps a little easier. So I've drawn the horizontal line. Now I'm going to project this. This is going to become our point A. We're going to project it up to here. And if you follow, there's some steps here because this one is a little complicated. And so I've given you the steps. So this is going to give me A. Now after I find that A, I'm going to find a, I think this is like a temporary A. This is not the actual true length of it, but it's just for a point of reference because I'm going to need it to be able to draw, project lines out, etc. All right, so after we've done that, we've connected the OA to the horizontal plane, and then we want to draw a perpendicular OA, so it goes through point 1. So what that means is we want to go through point 1, and we want it to be perpendicular, so we want it to go through there. So where are we hiding at? Hang on one second. Sorry, get that brain going there. I'm actually going to continue. There it goes. I'm actually going to bring that out because what we have to do is we've got to find a perpendicular through this OA, that line, through line 1. Where's line 1? There's line 1. And to do that, it's actually easier if I take this. Sorry, it's catching on papers and books there. Here we go. Is it still on? It didn't move? Yeah, I didn't move. Okay. So what I did is I lined that up with that line so that I can now draw my horizontal through. And this is actually point 1. I know the one that may be over here, but this is actually at the point 1. So, okay. And then once we've done that, we want to continue drawing this perpendicular lines here. We want to pull lines, the 2 over and the 1 over to where it hits here. Hang on, move this so you move it just a little bit so you can kind of see what I was doing. I was trying to show it and get it in their view. Dang it, still not in the view. I'm going to move it up. Make sure that's again lined up. There we go. That might be a little better. Notice I'm not getting real crazy with the length, but I am drawing it over so that I can see it. All right, so what we need to do now is we need to find the true length of this line 1, 2. And so to do that, we're going to have to find some measurements. So again, we need to find our little a and our little b, that same one that we keep using repeatedly, because it just makes things a little easier for us to find. So let's flip it around where you can hopefully see the whole thing again. So I need to find little a, and then I need to find B. And what I should have done, and I wasn't thinking what I should have, as I should have went ahead and just drawn those lines and lined everything up. Go ahead and do that right now, because that makes it easier to transfer. Make sure it doesn't shift on you, because I think mine shifted. So sometimes you have to put more than one piece of tape down, and that's okay. There we go. That's all I'm doing, is just connecting so I can actually get real, true measurements. So now I'm going to take the A and transfer A here, and then I'm going to take the B and transfer B on this one. There we go, A. A. B on 2. Oops, and I actually didn't draw that one quite out far enough. That might happen. It does. Line it back up with your straight edge and just bring the line out some more. It's okay. There it goes. Okay. Make sure I didn't lose my B. That's my distance B, so that I can get the true length of 1, 2. So that gives me the true length of 1, 2. All right. Sorry, my nose is itching. Somebody must be talking about me again. So now we're going to continue the next step. So we just found the true. Now we're going to do the perpendicular lines to the true length. So we're going to take this and flip this around where this kind of lines up with our straight edge so that we can get our perpendicular lines. There we go. Tape it down so it doesn't move. Actually switch to the lighter lead, not the heavier lead, remember. That's where it actually hits there, so I can draw up. Okay, so now I'm going to draw a perpendicular up from each one of these points. And now what we're going to do is we're going to draw a line parallel to the true length of the line through point 2. So I've done that and I got my perpendicular. Now I need to get some other smaller letters, A, B, C, D, so forth. So let's flip this around. So let's go look and see the ones that we need. So we need to find measurement C, D, C and D. I think that's just C and D if I remember correctly. Yeah, C and D. So in that particular case, this is our C. And then this distance here, from here to here, is our D. So there's that distance there to the fold line here. So I just found C, and now let's transfer D. Find the measurement, fold line, mark it. That becomes our D. Now we're going to connect that one together. And this is where it gets interesting. So that's 1, and that's 2. Now what we need to do is with this line O that we've pulled through, because this is OA, so here it's OA, and so we're trying to continue it through, so we want to find the A so that we can find the O, essentially, because we know A is going to be somewhere around like right here, like that's like the A, that's what it's pulling through. So we follow that line through, and I'm actually going to continue it out a little bit more because I'm afraid I'm probably going to need to. Now the thing is, it needs to be a 45-degree connection. So let's get our 45-degree triangle. Oh yeah, hang on, I almost forgot we need to transfer the distance of true length, don't we? I need to get the distance of the OA, the true length of OA, which we found over here. And I need to transfer that on this. Almost forgot a step. Because this is the true length of OA. So I find that true length of OA, and I bring that same true length over here, because that's how you have to find the O. So you have to find out where O is going to be. So right here is where O is going to be. Take my 45-degree triangle, got to move this around a little bit on the paper, so I know it's going to go a little crazy there for a minute. Okay, there we go. I'm going to get back in straight. So now, see how I'm using my 45? I'm going to line up that straight edge with that straight edge, and the straight edge where it hits through the O. So again, straight edge here on the bottom of the 45. The other edge of the 45 hits here. Continue it through. Sorry. Oh, not cooperating with me. There we go. Take the tape off right now because I don't need it right now. There it goes. Get my darker pen, lead. So I just found the actual true length of OP. So we now have the true distance, or the true length of OP. So this is your true L, or the true distance of OP. So now I'm going to take that true distance with my dividers, and I'm going to take it and I'm going to find out where it hits here and where it hits here, so we can actually transfer those over, so we can actually find out where they hit. So there's that true length, right? To where it hits, and mark. To where it hits and mark, and then connect those marks. There's P. And there's P. And then if you take this measurement, and so we find that true distance of the OP, measure it with your engineering scale, and each one is equal to 10 feet, and then you can figure out, like, okay, how many feet is it going to be? And then of course you need to figure out the same Houston and put the date, all that, so you need to fill in right over it. Remember to actually legitimately write over it. I've given you some of the letters. Fill it in. All right, now we go on to the next one.